Welcome to Maths for All. I'm Aisling Flynn. This is Statistics 1.1, Gathering Data. Okay, so today we're going to look at uses of statistics, gathering data, how to question, and samples and populations. So who uses statistics? And we have some picture cues. This is a picture of our government buildings in Dublin, the Dáil, and governing bodies use statistics to make decisions for our population and our country. At the time of the making of this video, we're in the middle of a pandemic around the COVID-19 virus, and we see statistics on the news every day. We're tracking numbers of cases, of hospital numbers and hospital capacity, and we have that famous R number, which is the reproduction rate. If one person with the virus has it, how many people on average do they pass it on to? And we need to get an R number of less than 1 for the numbers to drop significantly. Okay. Political scientists, historians, people who study populations use statistics. This picture here relates to the fall in populations at the time of the famine in Ireland. Politics again. Okay, here we have results of a political poll, so coming up to an election and after an election, when the votes are being counted, there are lots and lots of statistics. Here we have a picture of some school children. So the governing bodies we mentioned above would have to keep an eye on the birth rates of a country to predict how many children will need school places in 4 or 5 years' time, and so we need to prepare for that in advance. And likewise, people nowadays with better health services are living longer and longer, and so governments have to see this, and they have to provide enough residential homes, etc., for the older population. They have to be prepared. And here is a road safety stat, so it's used in PR, in advertising to get people to drive more safely. Okay, and of course there's lots more. And here's some more. This is a business strategist, so somebody who's planning their business in advance. They should have lots of statistical homework done. What size is their market? What proportion of the market could they take for their business, etc., etc. What are the predictions? How much money can they take from it? Okay, here's Paddy Power, bookkeepers. So much statistics. They have the history of every horse that runs and the ones they are running against, and the weather conditions and the ground conditions, and they have to predict which horse might win a race, and they have to set their odds accordingly so that they'll spread their losses if a certain horse comes in, etc. Okay, the stock market. Okay, so not unlike gambling, share prices are bought and then they're watched rise and fall, and when should you sell, etc. Okay, scientific studies use statistics. Many measurements are taken over and over again, and averages and trends are looked for. Okay, this picture here shows sports statistics. Okay, so each player has his own statistics. Nowadays in professional sports, so many statistics are taken. Players wear GPS trackers as they play a game. How many kilometers did they cover during a game? At what stage should they be substituted? Maybe not in basketball here, but in games like rugby and soccer. Okay, it's all taken to account. Now, the next thing you should bear in mind when you see a statistic is should you believe it or not. Okay, so here's a cosmetic advertisement. Okay, it's called for a product called Skin Perfection. Okay, and it says, what does it claim to do? So it claims that your pores will look undetectable. Okay, so that's what it claims, but I want to draw your attention to the statistic down the bottom. 71%, which is just above 2/3 of 123 women agree. So you have to decide, do you believe that this product will make your pores look undetectable? So 2/3 of 123 people, now that's about 80 people. You're going to take the word of 80 people, so it's not a great statistic, to be honest. So what would make it better? Well, maybe if they did 1,230 people, then you have 800 people vying for the product. That might be a better statistic. Okay, so always look carefully. Tone appears more even. Okay, what about this one? 9 out of 10 cats prefer Whiskas. Do they? Well, who asked them? How do they choose? How do they communicate this? Okay, because what is funnier than talking animals and stupid people? Nothing. Okay, so questions. This is how we get information or get data. Okay, and there is such a thing as a good question and a bad question in statistics. And we'll go through the main points here by asking a few questions. So the following questions are based about a scenario where a new sports centre is opening up in the area or in an area. The owners want to know how many possible future customers they might have. They carry out a questionnaire, sometimes called a survey, and ask this question. Do you play sports or would you like to play sports? Yes or no? So ask yourself this question. What is your answer? Is this a good question? I would say no. Okay, why or why not? Well, did you answer yes or no, or did you have any trouble? There is actually more than one question here. So, do you play sports is one question. So say perhaps I don't play sports right now. My answer is no. Or would you like to play sports? Well, yes, I would. So I want to answer yes. But that's two different answers for two different questions. So this is not a good question because there is more than one question to answer. Can you write a better question to find out the information needed? So you could pause the video here now and see what you might write instead. So here's a revised version. You can split up the questions into two different questions. Do you play sports? Yes or no? Straightforward. If there was a sports centre near you, would you play sports? Yes or no? So this is getting more to the point of what the owners of the new business need to know. So one question is good. Question 2. A new sports centre is opening up in the area. The owners want to know what kind of facilities to provide. They carry out a questionnaire and ask this question. What is your favourite sport to play? Soccer, basketball, tennis. Okay, so they're looking for the interests of the local community. So answer that question for yourselves. Did anybody have any difficulty answering the question? Is it a good question, do you think? I would say no. Why or why not? Well, not everybody can answer this question. There are only 3 sports to choose from. So what is your favourite sport to play? Well, what if my favourite sport to play is badminton? I can't answer the question accurately. Okay? So it doesn't allow everybody to answer the question truly. Okay? So can you write a better question to find out the information needed? So pause the video there, have a go at writing a better question. So this might be a better question. What is your favorite sport to play? So firstly, I've provided many more options. Okay, I've added in rugby and hurling because they're popular in my region. Okay, but I've also included a space for other sport, and there's an empty line for the person questioned to write in any other sport that they like. Okay, so for example, badminton. And in addition, there's a space for somebody who has zero interest in sport. They can tick none, so everybody can answer that question. Okay, question 3. A new sports centre is opening up in the area. The owners want to know the age profile of their potential customers. They carry out a questionnaire to ask this question. Okay, so the age profile is what they want to know. What age are you? Young, middle-aged and old. Okay, I'm not going to say what age I am, but I'd like to consider myself as young. Okay, not quite middle-aged. All right. Is this a good question? I would say no. Why or why not? Well, it is unclear what is meant by young, middle-aged and old. Okay, so most people will go younger than they'd like to admit. Okay, but it's unclear is the problem here. So can you write a better question to find out the information needed? So pause here and see, can you write a better one? A better question might be, what age are you? And you give specific numbers. Okay, less than 18, 18 to 30, 31 to 40, and the numbers don't overlap. Okay, so it should be clear to each person where they should place their tick. Okay. A new sports centre is opening up in the area. They wish to provide healthy lifestyles and wonder if their future customers are interested in improving their habits. They carry out a questionnaire and ask this question. So this is question 4. People live longer when they have healthier lifestyles. Do you wish to improve your eating habits and levels of exercise? Okay, so there's a couple of problems here with this question, I think. Firstly, from question 1, there's 2 questions in there, eating habits and also levels of exercise. That's 2 separate things to improve. Okay, but another problem with this question is the first sentence. People live longer when they have healthier lifestyles. Technically, that's not required to ask the question. And also, if you answered no here, I don't want to make any changes, you'd probably be led to feel a bit bad. Okay, is this a good question? No. Why or why not? This is a leading question. Of course, people are going to be pushed towards answering yes. Okay, so they may not answer honestly. Okay, so leading questions push you towards one answer or another, and they don't give realistic, true and honest answers. Can you write a better question? Okay, so here's a better question. Okay, so this is a different style of question. Okay, and it gives the person who's answering number of separate questions and also some suggested answers. Okay, so this can lead to people being more honest. All right, how do you rate your eating habits? Circle where appropriate. Okay, very healthy, somewhat healthy, neither healthy or unhealthy, in the middle, somewhat unhealthy, very unhealthy. Okay, and the same for exercise levels. And if the proper facilities and advice were available to you, how likely are you to improve on this? So if there's a maybe a little bit, you get somewhat likely. Or if they said very likely, well then the sports centre owner, the new owner, would be encouraged by that. Okay, so different style of question there. So in conclusion, good questions should have only one question. Okay, so one question only at a time. allow everybody to answer, so there should be enough choices that everybody can tick a box. They should be clear. The age example there, it should be clear to everybody which box they should tick. And they should not be leading, so they should be unbiased, neutral, and people should feel they can answer honestly. Okay, the next thing that's important to consider when doing a survey or questionnaire or study is sampling. Okay, so a new sports centre is opening up in the area. The new owners carry out a questionnaire using the good questions above. Okay, so now they go to the local GAA field one evening to carry out their questionnaire. Okay, so GAA is Gaelic Athletic Association, so most likely football or hurling. Okay, and to carry out their questionnaire. Is this a good idea? So they're going to get lots of people of an evening out and about, possibly lots of potential customers. Okay, but I would say no. Why or why not? Well, they are asking a group of people who they know are already interested in sports. Those sports might have, or those people might have their whole week booked up already, various training sessions. Also, they won't have reached the person who doesn't have a sports team, who doesn't already train, okay, or who is interested in a different sport than GAA. Okay, this sample is biased. Now, what does that mean? Now, the sample is the group being chosen to question, to test, or to study. So you can't ask absolutely everybody in the area because there's too many. Okay, but you can ask a smaller group that represent the full population. Biased. There is bias when a study gives results that are untrue for the population as a whole. Okay, so this example here, they're only asking sporty people. Okay, there may be 100 people in the field that night. The whole rest of the area might have zero interest in sport, and they won't have found that out. Okay, and the population refers to the whole group for which you want results. In this case, all the people in the area. Okay, so where should they go instead? A new sports centre is opening up. The new owners carry out a questionnaire using the good questions above. The population is all the people of the local community. The sample must be chosen at random. So random means that you have lots of different types of people and they each have an equal likelihood of being chosen to question. The sample must be large enough and it must represent all groups in the community. Where could the owners find their sample? What groups of people need to be included? And how many people should they ask? Okay, so where could they find their sample? Well, you want to get all sorts of people, perhaps outside the local supermarket, because everybody has to eat and everybody has to go to buy things. Okay, so you get all sorts of people there. What groups of people need to be included? Well, outside the supermarket you might get old people, young people, middle-aged people, active people, not so active people, healthy people, not so healthy people, men and women, children, the whole lot. Okay, and how many people should they ask? Well, they should ask as many as they can. Okay, because the more people you ask, the better your results will represent the full population. Now, let's say our new business owners took a different approach to carrying out their questionnaire. Let's say they had a phone book or a census form of all the houses in the area, and there were 2,000 houses in the surrounding area that they were looking to target. Okay, so how would they choose a random sample? Okay, so given a list of 2,000 people or houses on a spreadsheet, how could you generate a simple random sample of 50 people to question? Okay, a random sample means that each person on the list has an equal probability of being chosen for the sample. Each person on the list could be assigned a number in order from 1 to 2,000. So you could give them each a number down the list, and then a calculator or computer can be used to generate a random number between 1 and 2,000. Okay, there's a video coming up to show you how to do that. Okay, so it's equivalent to pulling a name out of a hat. Okay, you could put all the names in a hat and pull it out with your eyes closed. It's random. Everybody has equal chance. Okay, and then the numbers that come out, well, those people would be included in the sample. Okay, and the sample should be a mixture of all sorts of people because it's done randomly. And this would be repeated until 15 people were chosen. The advantage of a simple random sample is it removes human bias, meaning you don't know what the person looks like or what their age is, are they approachable, whatever. Okay, so you're completely blind as to who you're going to choose. The disadvantage is, in practice, it can be difficult to obtain complete lists of the full population which is to be studied because of data protection, etc. Okay, so here's a video to show you how to generate random integers being whole numbers.
Firstly, notice above the decimal point button, we've got a random number in yellow that returns numbers between 0 and 1, but the red one is for random integer, so random whole number is what you're looking for. Okay, so to select random or red writing on your Casio calculator, you use the alpha button, that's for red. Okay, and press the decimal point button for random integer. Now you're allowed to select the range of numbers you wish to include. Okay, so if you're starting with the number 0, if you want to include 0, you can press start with 0, or in this case we want to go from 1 to 2,000, so there's a list of 2,000 names. So number 1 is the starting one, and then we want to put a comma. So if you look here, there's a comma in yellow writing. To select yellow writing, use the shift button and comma. And then our last number we wish to include is 2,000, so top of the range. Close your brackets and now you're ready to go. So pressing the equals button repeatedly will return a random integer between 1 and 2,000. So our first one is 691, so person number 691 will be included in our sample study. Person 1802 also, and you can repeat this as many times as you wish. In the previous example, it's looking for 50 people or 50 pieces of data for the sample.
Okay, now it's time for you to do it, to check what you've got from that lesson. You can check with your quiz and with your written exercises. And here's a bit of a glossary.